Hey guys, so welcome to Wednesday. We are doing an intro to function transformations, which basically means we're taking a graph and we're moving it. Okay, so I know a lot of you guys have seen at least some type of this in eighth grade. And it included when you made things big or smaller, when you moved them to the right or to the left. Um, and so we're going to start with a quick review of parent functions. And the reason for that is in at least today's examples, they refer to parent functions because they use them as like a starting point and then they move the graph left, right, up, down, right? So just review that. And here's a little hint that when you're in Desmos activity, they do ask some information that is on here. Okay. Just remember also that the parent function just is the simplest way to write whatever that function is. And these four functions, right, or types of functions, absolute value, radical or square root, as we call it, quadratic and linear, you should be able to identify by either a table, a graph, or an equation what type of function it is. Okay, so as soon as I see an x to the second, quadratic. I know that just by looking at it. I know any equation with x to the second in it has to be a quadratic. Okay, so review those if you need to, and definitely for today's lesson, but in the future, feel free to come back. All right, so transformations, again, they are how we move a graph, but we are only focusing on a few of these. So if we start from the bottom, these two are what we call dilations, right? So they'll take a U shape and they'll make it wider, they'll make it narrower, they'll like squish it up, they'll like make it, they'll pull it down. So we are not focusing on dilations today, but just so you know that that's what they are, and we might see it in the future. The bulk of what we are doing is right here. And these, where we're shifting up, down, left, right, those are called translations. Okay, so these are what we're focusing on today. Translations. Of course, it has to be a long word when I'm writing it out like this. But I don't think I'll ever be not upset that I have to write all these things out. It takes forever. Anyways, enough of me moaning. Then reflecting over the x-axis. So we are focusing on this part of reflection. You can reflect over the y-axis too. Great. We're just not doing it here, so we're not going to spend a lot of time on that. All right. So the other thing I hate about writing all of these things is that then I need to erase it. So as I'm erasing these, go through and look at what a reflection over the x-axis is. Okay. Oh, one more. Got it. All right. So this blue quadratic, and again, just by looking at it, I should know it's a quadratic function, right? And we also call this a parabola. This blue parabola is my original function, and the red one is how I've translated it. So if you notice, the blue one is a U shape, right? And then it's just like if you were to fold this, the x-axis, right? If you were to fold it, you would get like a stamped imprint of it looking the other way, the opposite way, okay? So we've just kind of rolled it over the x-axis here. All right. And the way you do that is you just put this negative sign in front of it. So if I have here, I'm going on Desmos. Let me just type this up again. Okay. So again, I really highly recommend you using Desmos to test out your equations. And I just go to the graphing calculator. All right. So like if I have y equals x squared, okay, if I just make that a negative, okay, it flips. So here, let me just keep that. That's the parent. The red is the parent function. And now I'm just going to make it a negative x squared. Okay. All right. So I can do that there. Let me see. Let me just try to do y equals 2 to the x. What kind of function is this? Test yourself. Okay. So if you said exponential, you're right. And so now I'm going to say y equals negative 2 to the x. Okay, and see, let me erase these so that you can see, right? So the green is the parent function for exponential. And if you just were to like flip that down over the x-axis, you would get this. Okay, so all I'm doing is making them negative. All right, so let's go on to the next one. Here is like the real bulk of it. All right, so when I have a number added or subtracted to the outside, okay, then that tells me I move it up or down. Okay, if I have a number added or subtracted to the inside with the x or whatever your input value is, that is going to move it to the left or to the right. Okay, and this is the tricky one. It moves it the opposite way of what you think. Okay, so if it's positive, right, if I add a positive number here, I'm actually going to be moving it to the left that many steps. Again, I hope that's left for you guys. Okay, and if it is a negative, I'm moving it to the right that many times. So it's the opposite of what you would think. All right, so again, I'm going to go back here to Desmos, and let me start again with like, actually, I can do this. So, all right, so let me just put that back up there again. All right, so here is my parent function, right? So again, remember, when I am adding or subtracting something with x, it's going to move it to the right or to the left. So let me try that. Y equals 2. And now I'm going to put a parenthesis. So I know all of this is in the exponent part. So I put x. And so I don't know. Do I want it to go to the right or to the left? All right. I'm just going to pick a number. So I'm going to say plus 3. So pause. How do you think it's going to move it when I put plus 3? And I'll give you a hint. It's either to the right or to the left. Plus 3. Okay, so see that this green is the parent function, right? So I can pick any point on this green and I can move over 1, 2, 3 to the left. So this moves it 3 to the left. All right, again, it's different than what you would think. Okay, now let me go back in here. And now I want to just add or subtract something to make it go up or down. This is what you would think. If I add something, it'll go up. If I subtract, it'll go down. So let me subtract 5. Okay, so now remember, I was here, and now I'm going to go down 1, 2, 3, 4, 5. Right? And now I'm on my translated graph. And I can do that with any point. So this made it go 5 down. Okay? So here, if I'm here, I can go 3 to the left, 1, and remember, 2 of these boxes is 1 space. All right, 1, 2, 3. Wait. Okay, so I've done 1, 2, 3, and now 1, 2, 3, 4, 5. Okay, so 3 left, 5 down. All right, let's do a few more practice. All right, so let me erase this. Okay, that's a good beware. All right, people always make that mistake, so it's a good thing to practice on. Again, remember, there's no such thing as someone just being is smart or not smart. It's just about, do you have the skill? And practice is one of the ways you get that skill. Okay, so example 1, here's my parent function, and here is how it's being translated. Again, with the x inside, I've got a -3. How does that move? 3 to the, I hope you said right. Remember, when it's with the x or the input, it's the opposite of how you would think it would move. All right, so this gray is my parent function, right? What I'm moving it from. And I go 1, 2, 3 to the right side, all right? And now I have this 2 outside, and that moves exactly how you would think, up, right? So I would move 1, 2. The reason this blue is here is because the example is trying to show you one thing at a time, right? So this red is actually the entire transformation. So from the original function, you went 1, 2, 3 to the right and 2 up. And again, you can do that on any point in your original function, and it will get you to the corresponding point on your transformation. So if I pick here, I go 1, 2, 3 to the right and 1, 2 up, right? And there's my corresponding point. Okay, so let's go to my next example. All right, so let me erase this. And here we have a function that has been shifted 3 units to the right and 5 units down. All right, see if you can choose the one. You have until I finish erasing this. Okay, 3, 2, 1. All right, so 3 units right. Remember, that goes inside, and it's the opposite of what you would think. So right, I think positive. It's the opposite of what you would think. So it would be one of these two. Okay, and then it goes 5 units down. That's exactly what you would think. So it should be this one. All right. Again, I did that really fast because I'm trying to save a little time on the video. Always go to Desmos. Always check your work. Don't just think you remember the rules. Okay? All right, and we just have one more, and then we're done with today's video. Okay, so here we go. Here is my parent function. So think, what type of function is this? You should know just by looking at it by now. All right, I hope you said linear. So if I want to shift it up, let's say I want to shift it up 5, then I would put x plus 5, right? That shifts it up. If I want to shift it down, I can put y equals x minus 2. And that minus would make it go, would shift the whole thing downwards. All right, I can do the same thing here, right? So say I want to take this function that I have, I want to shift it down, right? I'm going to do the same thing. And that's an x. Okay, and let me keep these colors since I'm doing that. All right. So, oh, and it's Spirit Week, and I'm using school colors. I did not plan that, I promise you. Okay. And realizing that made me mess up a little. So I, again, have my parent function, and I'm going to add, right? So in both of these cases, the plus 5 moves that function up. The minus 2 moves it down 2 units. Okay, so now if I want to shift it to the left, right, I'm going to say y equals, and linear is kind of a funky one because if you move it to the left or to the right, it's still pretty much the same graph. Okay, so but let's keep it with the x, right? So again, it's for linear. For other ones, it's a lot more, you know. So wait, so we have 5, and if you notice, right, when you do these both on Desmos, again, this is just specific to to linear, it's going to have that effect of moving it left and moving it up. Okay, so just in other functions, it's a little bit more clear. Okay, so again, to the right, I would subtract it if it's in with x. Okay, and yeah, those two are the same because it's linear, right? Other ones aren't like that. Okay, for example, this. So if I want to move it to the right, I'm going to have 2, and then with my exponent up here, I'm going to have x minus 5. Okay, and if I want to move it to the, what did I do? I did to the right. So I'm just trying to keep my color codes. All right, so if I'm moving it to the left, again, I think if I'm moving it to the left, I'm thinking subtraction. It's the opposite of what you would think. So it's plus. Okay, so here it's a little bit more obvious, like how moving it up or down would affect it a little different than moving it to the left or to the right. Reflect over the x-axis. So again, this would just be y equals negative x. And this one would just be y equals negative 2 to the x. Okay. All right. So when I'm looking down here at 1, describe the graph of b of x. So it's written in function notation, okay. B of x equals negative. Oh, so as soon as I see this negative, I know that it is flipping, right? It is reflecting on the x-axis. So I'm just going to put r of x-axis. All right, so that I don't have to write it all out because you guys know I am lazy about that. Okay. All right. This x plus 3 right here, again, it's with the x. It's moving it left or right and the opposite of what you would think. So this is actually going left 3 units. Okay, I'm glad that you guys can hear me because I feel like this writing is not showing up. So it goes left 3 spaces. Okay, spaces. I can do it. Okay. And then this negative 3, what does that do? Right? So this negative 3 makes it go down 3 spaces. Down 3 spaces. Okay. So if I'm given a function right here, f of x equals 2 to the x plus b, this plus b means it's going left however many spaces b is, right? And this plus c means it's going up however many spaces c is, okay? So that's how it affects it. So the b makes it go left and the c makes it go up. And the way I know that is one where it's placed, like the b is with the x, meaning it goes left or right, and plus b specifically means it goes left, okay? And again, the placement of the c, the fact that it's separate from the x, okay, means it goes either up or down, and the fact that it's plus means it goes up. Okay, so that is it for me. And I hope you enjoy your Desmos, have fun with it, and let me figure out how to stop this. I will see you guys tomorrow.